Hello everyone, welcome back to This Is Not a Science channel, and this is our other episode of biology. And today we will be looking at diffusion and osmosis. And those who have watched my first video, which is a chemistry video, might have a bit of impression of diffusion. So we're going to discuss in this video sort of a review of diffusion, and we will discuss how this can actually link to osmosis, which is another different version of diffusion. So let's start. Let's talk about diffusion first. So what I wanted to do right now is to recode the definition of diffusion. So here we have the definition of diffusion. So diffusion is the movement of molecules from a region of its higher concentration to a region of its lower concentration. Molecules move down a concentration gradient as a result of their random movement. So again, let's break down this definition in order for us to understand it. So when it says from higher concentration to a region of its lower concentration, basically means if you look at this diagram, we have solutes right here. They're kind of clumped up together. They're really highly concentrated. And what happens is they're going to start randomly moving around due to its random movement. And this random movement, from our very first video, we call it Brownian motion. So what happens is they're going to randomly move and they will bump into each other, which causes them to spread out equally. There are four key things that we have to remember that actually affects diffusion. So when we talk about diffusion rate, it's basically how fast something diffuses. And there are these four factors we have to consider: surface area, temperature, concentration gradient, and distance. So for surface area, basically, the larger it is, the faster molecules diffuse. Basically, you have more space for the molecules to pass through. And whereas temperature, when you have a higher temperature, the molecules gain more kinetic energy, which results in a faster movement and more random collisions, resulting them to spread out faster. And in terms of concentration gradient, if you have a really high concentration gradient, you have more solutes. And when you have more solids, there will again be more successful collisions between each other, which basically result in them spreading apart. And when it comes to distance, the shorter diffusing distance is, the easier it is for molecules to pass through. So if the distance is really short, diffusion will happen really quickly. Whereas if the distance is long, molecules take more time to pass from one end to another. After we talked about diffusion, sort of review it a bit, let's talk about osmosis then. What is osmosis? It's a different version of diffusion, whereas it's only involved with water. So let's take a look at definition of osmosis. So osmosis is the movement of water molecules from a region of its higher water potential to a region of its lower water potential through a partially permeable membrane. It's a bit similar to the previous definition of diffusion, if you can see sort of a pattern going on here. But in this case, it's only with water. So it clearly mentioned here, it's the movement of water molecules, so only limited to water, and from its region of its higher water potential to a region of its lower water potential. We'll explain this bit later on. And let's take a look at through a partially permeable membrane. So what does that mean, partially permeable? So we refer to something as it's selectively allowing certain things to pass through. So it is a membrane, it's a barrier, but then some things they can pass through, some cannot. And when we talk about this, we usually refer to the molecule size. So small molecules like water, they can easily pass through the permeable membrane, whereas something large molecules like glucose, we are not allowing it to pass through the membrane. So in this case, we are mentioning about only water molecules moving through the membrane, whereas other solutes like glucose, they are unable to move through. Now let's discuss about the most important thing, water potential. And water potential is represented by this sign here, a Greek symbol, which we call it a psi. And here's a formula we have to remember. Psi equals psi s plus psi p. Basically, water potential equals a solute potential plus pressure potential. And here are some rules that will explain this formula. So basically, normally psi p will be 0. What does that mean? Psi p right here represents the pressure potential. And if we are in a standard condition where our pressure is just the standard atmospheric pressure, then psi p will always be 0. It will not be affected at all. Whereas when we have distilled water, psi will be 0. What does distilled water mean? Distilled water means pure water, when we're not expecting anything else but water. So pure water, we have a water potential of 0, which is the highest possible water potential. So 0 will be the highest water potential. And when we start to add solute, psi will be negative, since solute potential, psi s, can only be 0 or negative. What does this mean? It basically means psi s represents how many solutes we have. The more solute we add, for example sugar, the more sugar we add, the lower the psi s will be, so the more negative it will be. So if you see a very negative water potential, then it's a very low water potential. When it's not as negative, it's relatively higher water potential. We got some questions here. I want you to tell me which one of these conditions has a higher water potential. So just pause the video right now and just drop down the answer. Which one has a higher water potential? Alright, I hope you came up with an answer. So still, let's take a look at it with a formula. So we got psi equals psi s plus psi p. So water potential equals solute potential plus pressure potential. Well, here we got, if we want to know the water potential for this one, we take 0 plus negative 3. We result in a negative 3 water potential. Whereas in this one, we take 0 plus negative 8. We get a negative 8 water potential. So obviously, this one right here, the left-hand side, will have a higher water potential because the one on the right-hand side is more negative. And remember, the more negative the water potential is, the lower the water potential. The more positive it is, or the less negative, it will have a higher water potential. We have to actually put it in practice. So we have a condition right here. We have a beaker, and in between the beaker is a partially permeable membrane. And remember, partially permeable membrane only allows water to pass through. So here we have one side with a lot of solute and one side with less solute, and I want to ask you, where will the water move towards? So pause the video right now, have a think. Where will the water molecules move towards? Which side will it move to? Okay, so now here's the answer. The water molecule will move towards the left, where there are more solutes. So I'll explain why is this the case. So you can see from here, we have more solutes than we have here on this side. So what happens is we have higher water potential on the right side, whereas we have a lower water potential on the left side. And if we recall, the definition of osmosis is when water molecule moves from a higher water potential to a lower water potential. So the water from this side will start to move towards the left in order to balance the water potential. So once water has moved to this side, we will have a generally higher water level than this side because we have to balance the water potential. So based on the rules of osmosis, where we have higher water potential moving to lower water potential, we will result in more water on the left side. This brings us to an end, and the next episode we'll be talking about how do we actually use water potential on cells and how it actually affects animal and plant cells, because water potential is extremely important in nature. A lot of things in our body or in plants or in other organisms depends on water, and especially water potential. If the balance is not reached, something terribly wrong could happen. So it's very important for us to learn how water potential actually functions in our lives. So make sure to like my video, subscribe to my channel, and share it to all your friends who hate science. And I'll see you next time. Thank you very much.